For PhD class, usually you don't check the video, but in case you really want, then we'll be there. So let's get started. Let's very briefly review what. Why is there? Okay, yes. Review what we have done last time, and then continue the journey. I mean, today the goal is to finish consumers, and then the assignment one will be released. As a TA said, it's optional, so you can you don't have to do it. If you want to do it, you get the full credit. I mean, if you don't do it, sorry, you don't do it, then you would have no credit for the assignment. But we didn't check out whether you do it right or wrong. But as long as the serious attempt had been identified, and and then we should have time to cover our producer slides. Okay. So just to remind you why we want to study consumer is we want to study how people make decisions, right? Because at the end of the day, we are business school, right? You look at how business works is involving human make decision, or these days AI make decision have also follow the same constraint, right? And so you choose consumer because we are all consumer at some point of time, and have been always almost every day we do it, and then so we know where well how we make decision. And what differentiates us from the undergrad is we build everything from math, or to give a solid foundation of what they are. And you may ask why math is because math makes our language very precise. Okay, of course you can use logic, but you can use English, that's fine. But math allow us to get to the point is very precise. And many of you who would do empirics, actually, when you do empirics, you also very precise, right? You run regression every data point. I mean, 1 is 1, 2 is 2, right? 1.5 is not 1, right? When the p-value is 0.05, it's different from 0.049, it's different from 0.051, right? You have 1 star, 2 star, 3 star, it's different, right? That's there, right? It's a precise stuff. So what did we cover last time is we start from the preference and go to utility and end with utility maximization and with the demand curve. Okay, but let's start with the preference, and the preference will derive utility, and utility is something you learn from your, if you do the intermediate micro, that is what we learn, right? Utility is just telling us, you give me an outcome, I tell you a number, right? And by using why have a number, because number allow us to calculate easier, right? When regression is use number, right? You don't use ordinal data, right? So it just collapse a multi-dimensional object into a single thing, right? That's why every day we talk about GDP, right? And single number that summarize the well-being of the country, or the stock market, there's many stocks, right? It's hard to keep track of thousands of stocks, but you use the single index like Hang Seng Index or S&P 500 or whatever index you think in your mind, that will be the thing, right? That is summarize the idea, okay? So the preference we start is, very quickly, the reminder, we start with the n dimension in the Euclidean space, which saying that everything the consumer only care is the consumption of the good, which can be described by quantity. Here we actually don't allow negative, right, by the construction, right? So everything, the minimum you do is to 0, and then you go to anything in the positive quadrant, okay? And then we just basically asking the consumer to choose out of this n-dimensional vector. And we start with what is preference. Preference is, math is a binary relation, basically telling you that how each element in this set are related, right? And we impose a constraint on what kind of relation they can have. And we impose what we call complete and transitive as a rational preference, right? And complete and transitive means complete means give me any two things, you can always say compare, okay? You can't say I don't know, okay? It's unlike classical Korean drama, right? A woman asks the man whether you like me or the other girl, right? Because they can't say I can't tell, but you have to tell, right? Either you're indifferent, okay, but you can't say tomorrow I like you, the other day I like the other girl, right? That's not allowed in our model, right? So you have to be very clear what's going on there. And same, the other one is transitivity, right? Which means that there's no cycle, right? If you A over B and B over C, A must be better than C. No, there's no cycle stuff. So if that's the case, we say that guy is irrational. And of course, by rational is in classical economics, people think that's a positive description, think people are rational. So this is what people is. And recently, the public people marketing would say, right, because people are behavioral, have some mental capacity, right? We try to be rational, but it's not there yet. So it's become a normative idea, is what we should behave. And if you're AI guy, then probably this is what you think that if you want to design an AI system, this is what you should have, because this is the best thing you should do, right? That's what the rational people should do. I mean, this, if you do something else, it's not very reasonable. And then because of the preference, we can define what's indifference, and that get with indifference curve you learn in the intermediate microeconomics. Okay. And also we define strict preference, okay, as well. So there's some assumption to derive utility function. The first assumption is monotonicity, which means that the more is the better. Okay, there's nothing where deep here except what we mentioned, commodity means goods. It's not bad, right? Always more the better. And the other assumption we impose is continuity. Continuity implies that if you change the consumption amount a little bit, okay, your preference should remain the same. So then there's no sudden change. And remember, the leading example of non-continuous preference is lexicographic preference. Right? I also mentioned last time is in the marriage market, right? Many of the case, not many, but some of the women may only demand, and men have to be 180, right? If you're below 180, there's no say, right? It's 180 and 179, right? 179, no matter how rich he is nothing, right? 180 has to be there, right? So that is something that lexicographic, right? Have to be 180, right? 179, no matter how handsome he is, how rich he is, nothing. Okay, so that is the idea there, and the mathematical idea is like this, right? If you have x is better than y, something near x, actually, or everything is near x and everything near y, okay, that has to retain the strict preference. So that is the idea, and we learned that by monotonicity, more the better, and continuity, we can always have utility function, right? Because we did the proof last time, right? By only using the monotonicity and continuity, you always have the preference, okay? So just to recap a little bit is, when we talk about the, you have a lexicographic preference, right? Then you can't have utility function, okay? You can't have that, okay? So that's a little bit more careful, but when you don't have that, then when the regression will be some issue there, right? Because it's not continuous. You can't use a number to represent that. So when the regression cannot use a standard one, because there's no, you can use not, basically what it means is you can't use one number to represent your preference, right? When we have lexicographic preference, right? But you say, for example, at the marriage case, right? You look at the heights first, right? Once height satisfied, go the other one, right? So it's not a standard number thing, right? It's kind of decision tree to go there, right? So have to be careful about this. If you think your consumer is, you want to model, is not continuous, then you can't use a number to represent his preference. Okay. And another assumption on the utility we impose is called convexity. And as we remember last time, convexity is to have a demand function rather than demand correspondence, is to make sure that you have only one number there. For every price, consumer will demand one unit, is not multiple solution as a unit solution, okay? And that convexity means that if you have any two bundles, right? So if they're similar, say suppose you're indifferent between the two, mixing them is always good, the easiest thing to think, okay? But this is equivalent to this one. Or you say if x is better than y, mixing x and y is still better than y. right? So that is something like very normal thing, okay? But of course, you may not like this. It's a more modern idea, right? You may think mixing is worse than separate, right? Suppose like this, right? You like chocolate, suppose, okay? And you like spicy food. I don't think you would like spicy chocolate come together, right? I don't think, I mean, maybe you like, but I mean, I don't like it. I mean, so that is the idea, right? Maybe you like some, I don't know, you like the salty pig head or salty pig leg, whatever, right? Or you like candy or chocolate, right? You don't like mixing together, right? So it's kind of weird, right? So that is what I meant. But then it's violating this principle. But in general, this is okay. You always have some what we call diminishing rate of substitution, right? Some the idea behind. But anyway, we said when you have monotonicity and continuity, you have utility function. And then the next thing to talk about is when we have a convex preference, what does it bias is we have a quasi-concave utility function, okay? And quasi-concave utility function actually will bias is a unique solution to the utility maximization problem, which we mentioned at the end of the class last time. And let me go to the main thing, right? The last time we covered is the utility maximization problem. So we consider the consumer is a price taker. So the price is given to him and he's small, but as I said, if you're firm, you're big enough in the market, you may move the market, and this assumption doesn't hold. But we start with something very simple. But it shouldn't affect too much of solution, just make the solution more difficult to solve. If you allow price to change according to your demand, it's possible to solve. Okay? And we assume there's a, from the sky, fall down some money on him, give him Y, okay, maybe from his parents or he worked very hard, but he get a Y income, okay, or maybe a stipend come out from nowhere from the sky to your bank account every month, right? So the UMP, the problem is amazingly simple. It'll be just the consumer choose a bundle, okay, to maximize utility, such that the choice is within his budget, right? He can't spend more than his income. And just to remind you, this model have to assume utility has to exist, right? Of course, if you don't have utility, then you have a preference, also a doable, right? You can maximize over the binary relation, but the math will be way more complicated and we can't use calculus, right? And you probably, people who do maximization optimization would know maximizing over a set is very complicated object, but this is the way to handle the problem, okay? And in the very end last class, we mentioned because of the budget set is closed and bound, right? It's a triangle, you can always find a maximum, okay? Because intuitively, right, just like you try to look at this set, right? You move around, you can't go out, right? The function is bounded, and you can always find some maximum there, because there must be somewhere, right? I mean, you can't go to infinity, you can't go to disappear, right? So there must be a maximum there, right? Because the function is not disappearing, right? So that means that it must be a maximum there. But this is a math result, so it's just okay. We just take the math result, and the next is very important, as I mentioned, right? If your preference is strictly convex, then your utility function will be strictly quasi-concave. And in that case, the maximization problem will have only one solution. Okay. Then we have a demand function, right? Now we have demand function. Otherwise, if you have more than one solution, then what's a demand function? That's nothing. You don't really know, right? Because given the price, there may be many demand. There's no down-sloping demand curve, right? Because it can be anything, right? It can be a set. So in math, they call correspondence, but I think in our application, that should be fine. Because if you don't assume that, then can be a lot of things can be there. Then when you run regression, that's a problem. And when you solve the equilibrium, you don't know what the consumer want, right? Because at this price, oh, you may say, okay, he may demand this good by 10 or by 15 or by 20. Then what do you say? Right? Or you don't have a precise prediction. So in order to have a prediction very precise, you need to assume people in one way or the other. Okay, but that is the sacrifice, but this is the benefit of assuming strictly convex. And the next is the result for monotonic, because goods are good, I mean, or the commodity are goods, means the more the better, then you would use up all the money, because in your model, money has no meaning at all. The Y has to use up. Okay, and I think last time we end with this main thing is to go to the interpretation of the UMP. All right? I guess at the end of the day, you solve the model, come up with a lot of things, and that is the main result, is to look at the first order condition or the optimal condition. And I guess at least when we talk about market, I think 8 out of 10 of the model will end up with this kind of marginal condition. Basically, just at the point you're doing make a decision, you will be at the point, if interior solution must be, you do more of this and do less of that, you'll be the same, because everything is continuous, it's marginal, it's like the marginal benefit to the marginal cost, right? So here what we do is the choice of the consumer is to consume, because Wawa's law tells us that he will consume, use up all the money. So basically, he's just asking the last dollar is either going to good I or good J, right? He spent all the money, and then suppose he give him $1 more or take him $1 from him. The question is whether he will spend on I or J, right? You give him $1 more, or we take away $1 from him, he will consume less I or J, right? Or we choose. And in the case where is optimal, it must be the case that he can't find it optimal to make the changes, right? You ask him to sell 1 unit of I, and then buy on J, is it going to be good, right? Like this, okay? Just to remind you what's this. This is the marginal rate of substitution, and this is the price ratio, but what's that, okay? Let's look at price ratio, that's easier to understand, because it's a price ticker, so you can trade anything in the market according to the price ratio. So suppose he sell 1 unit of I, what he get from the market is PI, because that's highest, the price of 1 unit of I. Then he going to spend all the money he get, which is PI, on good J. How many units he can get is over PJ, right? So just the right hand side is he give up I, how many units he can get from J. Okay, and that means that is he exchange ratio from the outside. Okay. And the left hand side will be the exchange ratio in his head. That is the MRS, is the slope. If you draw a graph, right, it's a slope on the indifference curve. We said what's these two, okay? Look at the numerator. Numerator is if I give him or take him away 1 unit of good I, how happy he is, right? So suppose I take away 1 unit of I, then his utility reduced by this much, right? And the denominator will be if I buy him 1 unit of J, right? Then it's how much he's happy, right? So the ratio will be just asking that I take of him 1, okay? I give him back this amount of J, then he will be same happy as before, right? So basically it's MRSIJ, right? It will be just I and J at this point, difference curve here, right? The slope of this point will be the MRSIJ, right? Because you're looking at, you take away, right? Take away this part, like take away 1 unit from him is unhappy, and this make him the same. So this is the slope of the indifference curve, MRS. So we're just asking that his trade-off in his mind will be the same, right? Because if this multiply this, right, then he is indifferent between the two action, right? So the left-hand side is, just to repeat, is in his head how we think about the two units between the trade-off I and J. And the right-hand side, how the market think about it, is aggregate. But remember, the market is just basically everyone's what it thinks, right? So in some sense, it's saying that everyone in the market at the end is saying I and J are the same trade-off, right? But this is aggregate, right? Because the price actually, if the market is efficient, is reflecting everyone's average or marginal trade-off between the two objects, right? But that would be the idea, right? So, and just to remind you last time at the very last point, right? So by looking at the price ratio and how much he consumed, right, we can trace out how he trade off the two objects, right? So that is because we can't read the MRS from the data, but we know this, right? And we know the quantity. As long as we make the U assumption there, some assumption there, and then some parameter assumption, then we can trace back the MRS. That's how we can estimate that. So I'm not going to further, but this is the math. To derive it is Lagrangian. If you forget, maybe you can look up with Wikipedia or other math textbook, but I will ask you to do this operation for assignment 1. Question 1, the assignment will involve 2 questions. One question is do this kind of calculation. The other question involves some proof. But just to make you feel a little bit feeling of PhD class. So these I think this last slide we cover is if you do the operation, reverse it, right, and figure out that this is equal to the Lagrangian multiplier lambda, and the lambda has a meaning if you do the M.Phil theorem. I mean, the Lagrangian problem, that is what's the utility that you would get if I give you $1 more, okay? And very often this is also an empirical question, because we want to see if too often we will try to measure this guy, okay? Is something that very people often care in economics, but not so much in finance, because this is kind of like how people happier if you give him one more unit of wealth. But this idea of M.Phil theorem, right, is very important because M.Phil theorem here, dy du, because means that you forget about the you change 1 unit of income. Of course, you should change all this, right? But M.Phil theorem tell you that the second order effect will be unaffected, right? Because you change the income, you will change the consumption as well. But at optimal, they cancel out. Okay, so what is left is just reflected by the lambda. So that's a very powerful theorem. But the first time if you learn it will be very puzzling. But anyway, just assume that I guess for the business school, I guess it's not too much worry about that. And one minor point I want to mention, which is obvious from the result, will be if your corner solution, which usually you don't care about that unless you do theory, is when some people consume 0 on that dimension, it must be the case that the marginal utility on that good must be less than, right, if you spend your money on that good. Okay, so that would be because you spend on that good by 1 unit, you need PI. Okay, and this unit of PI would carry lambda utility. So this money cost in utility, right? By 1 unit, this how much utility you have to pay, and this how much utility you get when you try to get 1 unit. Okay, so if you consuming 1 unit is going to carry that much utility compared to the money you spend, you don't spend on it. Okay, and sometimes useful because when you run regression and you see someone not buying something, you will illustrate this point. But usually your data will not have this feature, but at least you know interior solution may not be always the case, especially if you have a large amount of quantity of large variety of commodity, then the consumer may not consume every single thing. So that it's going to be helpful in some sense. And finally, a little bit technical point is try to say when the solution is optimal, because FOC is necessary condition, not sufficient. So we're trying to tell you that if continuous, concave, I think it's fine. Defensible is technical, but I think it's not a problem at all for our application. So that means that the FOC we got is optimal. Okay, so but once we have that, we have this, the end outcome is our graph is telling you that what is our demand curve, okay? And how do you get downward sloping demand curve is starting from here, okay? So what we get from the utility maximization problem is to tell us the what? Give me the prices, okay? Give me utility, and give me the income of the guy. I can tell you how much he will consume, right? And usually we take the utility as given. So that's why is the demand function is described by the prices and your income, right? Given prices and income, I'll give you this dog. And you turn out that this, because of the FOC, right? This indifference curve, and the price line will be a tangent parallel there. So because this point, this MRS, the MRS will be equal to price ratio. So this is exactly the graph that if you learn intermediate micro, this is, you learn from there, right? So, but we're now saying that this concept of two good idea actually generalized to n goods, okay? That is what you learn from the advanced level, is this thing holds for n, and also we learn why you have this curve in this way, because this is, you assume a convex preference. And why indifference curve in this way? Because you assume monotonic, okay? And why you have this point, right? Because of all the three assumptions, right? You have monotonicity, you have continuity that give you this indifference curve, right? The sake and conversely give you this in this kind of curve, right? And everything end up here. So some three assumptions to end to this point. Now, we want to talk some about property, and of course, this property may not be very meaningful by itself, but telling you that once you solve the model, you will want to derive some property, and this property will go into your regression. So that is, you probably don't care about how to solve the model, especially on the empirical part, but rather you care about the comparative statistics, because we can't observe equilibrium by itself, cannot be empirical test. But when you look at changes in the equilibrium outcome, what we call comparative statistics, then you can have testable hypothesis, right? Because we said there's equilibrium, our model is fitting that, but it can't really say too much. But we can say when some factor changes, some external changes, how the model changes, and you can fit the model to see. Okay, so that is the main thing here. So you remember our demand function have two parts, prices and income. So we want to see is how prices and income changes change the demand function, right? Because we can observe those. And you can see how people change the demand, you can also observe those. And by looking at this empirical observable thing, you can run regression, you can do a lot of analysis, right? So that is the idea why we want to look at this property. Otherwise, why we care about math? So it's not, the equilibrium itself is not important, it's not that important in empirics, but rather I emphasize is how the exogenous variable changes change the demand function and lead to some predictable outcome. Okay, so always the first one is rather simple, right? It's saying that homogeneity degree 0, which means that if we double any prices and your income, your demand doesn't change. What does that mean? It means that if your salary is measured and the price is measured in US dollar, or you measure in renminbi, Hong Kong dollar, and the price is measured according to the same currency as you do, that shouldn't change, right? When you run the regression, it shouldn't be matter with that what is the currency you're measuring, right? So that is the idea, okay? And there's no money illusion there, okay? And that is the thing. We scale the price and income, that's the same thing, right? We measure things, doesn't have a scale effect. Okay, this is, of course, if everyone take the macro classes, they will disagree. Okay, macro classes say there is money illusion. Okay, if the government print money, at least in the short run, the economy is going to boost. That's what the Keynes said, right? Keep printing money, actually people will consume more. But of course, we are microeconomic class. We don't go to the Keynesian world, but definitely there's something there, right? And people in the marketing may agree also there's something different. Okay, but right, because in marketing, right, $3.99 is different from $4, right? Although they say 1 cent, no one care, but you put the number, right? If say the computer costs you $10,000, it's different from $9,999, right? $1 makes something different, but we just forget about that part. Okay, I think this part is nothing to that much, but what is more is how your other property, okay, how demand changes income, and the price itself, okay. Yeah. So that would be, but the model actually don't say anything. Turn out to be very surprising, okay. The model itself, if you don't make any restriction, you can't really say your income goes up, which could you consume more or consume less, okay, because everything is possible, okay. For example, you learn under, I think you learn principal class, right? They say, well, normal good, inferior good, right? Your income goes up, right? Maybe you will buy an iPhone, right? And if your income goes down, maybe you have more demand for Android. Say, no, I'm not going to invent anyone, but just assumption there, right? Or if your income goes up, right? You may have a lunch in the hotel, right? If income goes down, maybe you have the food in the canteen, right? Something like that, income, right? And so that is something that is empirical question, right? And then this one on price, the question is like, again, it's marketing people will disagree, but what we figure out from empirics is if the price goes up, okay, people will demand less. This in general holds. But marketing people will disagree, right? Look at the designer handbag there, okay? If LV is selling $1,000, then it's a fake. No one would buy it, right? If it's 10,000, it's still fake, right? Have to be 100,000 people would buy it, right? Have to be in this way, okay? So it's given good, right? The price goes up, you would want to buy more, right? But in general, it's an ordinary good. And also how prices of other good changes affect the demand of my own good is not immediately clear. And it really depends on what the good of nature is, but we know that depend on the good or subtlety or complement, right? So if the other good price increase, okay, my demand would drop, then they are complement, right? If the other guy's price goes up and my demand would goes up, then it's substitute. I mean, you learned that in the principal class already, okay? But we'll talk about a Slutsky's equation style equation to give you a more favor once we finish the other set of problems. So the red box is something I expect you to know very well because this appears in your assignment and expect to appear in the exam. Is how to solve a real problem. Suppose you are a consumer of utility of square root of two good, x1, x2, this product, square root of the product. Okay. And the question is, how can we derive utility function? And remember, this product, take the square root, is a special case of Cobb-Douglas utility function. Okay, the symmetric case. And you should, I don't want to spend time go over the math, But if you do, then you can ask the TA. The TA will go over that I think at the end of next class. He will go over an example, and he will do everything there. Okay. So, but I left it for you to have fun with the Lagrangian. But I think it's rather standard at the PhD level. I think it's an insult for me to go over this detail one by one. But to be sure, if you have still a question, talk to me in the break. I can tell you how to do it. But otherwise, you can go home, have fun, and then your problem, let me know. So here is normal good, inferior good. Okay. So here is the case where your income goes up or goes down, right? This income is just represented by the budget line. And you can see this normal good for the both, because when it goes up, both consumption goes up. But for this one, okay, X1 is inferior good, but it goes up, you consume less. Okay, so you can imagine X1 maybe money you spend in the canteen, right? And X2 maybe money you spend in a fancy restaurant, okay, for example, right? You have more money, you consume less on the cheaper food, okay, for example. Okay, and in theory, it's possible that the price changes can lead to different consumption. So in this case, price of good 2 will be the same, but if you move from here to here, which means that the price of good 1 goes down, right? Price getting cheaper, okay? And usually when we talk about order demand curve, right? When you fan out, usually good 1 would consume more, right? That means this is a downward sloping demand curve. This is a standard case, and we always observe in data, okay? But it's possible, very surprisingly or not, in theory, it's possible that price goes down, the demand can drop. I mean, this in theory, but I think so far, after 100 years, no one able to convincingly prove this ever a case. Price, I mean, goes up should not, right? Price goes up should not increase your demand. Okay, of course, as I said, marketing people would disagree, but I would defend in this way, because you buy a handbag, it's not just the handbag itself, right? It's something you would have some image there, the social status there, showing that you're good, right? And that's why La Boo is so famous, right? La Boo, everybody, I mean, the guys know about La Boo. Yeah, La Boo is evil, right? Anyway, La Boo is let's show La Boo. La Boo is invented by a Hong Kong guy, so relate to us. This La Boo. La Boo. Okay, whatever. So why La Boo is got so expensive, right? Because it's difficult to buy, it's expensive to buy a new handbag, right? But it's much cheaper to buy La Boo. And you can buy expensive La Boo, and to show off you have money, you have taste, you have what, right? So the same idea. Okay, not just for the lady, but actually for the man, right? But not as here, but people in the West drive and they want to buy a very big car, very fancy car, right? And buy the racing car, have to make the engine sound, right? So the same idea. Show off, I mean, the more expensive the thing is, right? But anyway, the same idea there. And also we have complement substitute defined in this way, right? The price of other good goes up, is my demand goes up or down. So I think this is a definition we learn in the undergrad. Okay. So we want to point you to another important definition, which often you would estimate in regression, in empirics. It's called elasticity substitution, which essentially the definition is not difficult, but looks a little bit crazy. Okay, you can see it's a negative of the differentiation of a log. Okay, but don't be scared. Log, if you learn regression, log is just percentage change, right? So look at how the two good you consume in percentage changes respond to your change in the marginal substitution. Okay, so that is the idea. Or if because of the market, MR is your price, right? So just like how your consumption changes according to price changes, right? So just like this good change in this price, relative price, and how is your demand response, right? It's very simple thing. Okay. So if you know this, the random regression, right? This what it means is look at the price rate, consumption ratio, log it, run the regression over the price ratio, log it. That is the substitution there. Okay. And this is often estimated in empirical studies. Cool? So that's something that you would be doing. That's why I mentioned. And why this is good? Because it's very convenient. When you consider the very often case the model, you have n-dimensional good, and it can be actively separable. You add them up, okay, and each one raised to the power delta, and the delta will be related to substitution in this way. Okay, so and you may ask, okay, what does it bias? It's very simple, and turn out that this seemingly simple utility function form actually include the three things we mentioned: perfect substitute, perfect complement, Cobb-Douglas, and even more things, but this is three of them. So that means that if you really want a model, it's very general, you don't want the special cases, you can start with this one and everyone use it. I mean, in the all the literature until now, okay, this is the CES model, okay, and even you find the recent paper in macro or finance, macro and trade is all they use that one. Of course, this is a single CES. Some people they use double CES. Okay, at least not just in the consumption, people also use production as well. Okay, in the supply chain idea, you combine different products to make the intermediate good, and you combine intermediate good to produce final good. So it's a double CES, multiple layer. You can have a triple layer, so on and so forth. So that is some idea. This is a very commonly seen function, and then this is you can easily derive many results from that. Okay, and the other elasticity is called price elasticity, also very commonly estimate. Okay, is how the change in price affecting your demand, right? And basically this is the demand curve, right? And this is actually, and marketing is even more estimated, right? Because this is actually what most firm is doing. Why? Because probably you will see in the next class, when the demand is inelastic, the firm would have incentive to raise price. Okay. If your demand inelastic, then the price should drop the price. Okay. So that's why this will tell the firm whether the price will go up or go down, right? That's why when the firm or all the marketplaces or the supermarket, they keep changing the prices, what they're doing is to get your elasticity. Once there is elasticity, they know whether the price go up or go down to adjust. So this is often done in the marketing. I mean, because they want to see if I increase in price by how much percent, whether your consumption will change, right? So you can see this imply change in price, you will spend total more, right? So that's why you hint in the next week, if you are the guy who is selling the good, right? In this case, your monopoly, you will increase the price here, right? You will increase the price such that you reach to this region, you can't increase price anymore, right? So that would be somewhere your result, okay? But that is something really people really estimate all the time because it's easy to run regression, right? The left-hand side is how much they buy, right? The right-hand side the prices. You just run the regression, right? then you can estimate those because you change the price by yourself as a firm. So there's no endogeneity issue there, right? Just because you change the price, right? You are doing experiment on that part. So that is something that have no problem of empirical identification issue there. So I'm not going to talk about the black thing. So before the break, I want to go to this very important function. It's called the indirect utility function. And usually a lot of time when you start the model, you don't go with the utility function. Instead, you actually go with this one directly. Okay, utility not depend on. You don't start with the demand function. Instead, you start with this directly. You assume utility is based on price and your income. Okay, but of course, this is already you just solve the model and put it back, give you this utility, which will give you example very soon. Okay, but here what is said is this function simply just you put your Marshallian demand function into utility, you get this function. Okay, but give an example. You see what I'm doing. Let me give an example first. So the example like this. I have the utility function. It's Coppola style. I solve it in the example that I didn't go through, but you just put this result back into utility. This is the indirect utility function. Okay. And why I want this? Why we wanted this? Because remember utility function, original one depend on quantity consumption, right? So what it means is I need to observe the quantity people consume before I can estimate utility. But for this one, I don't need. I just need to check how much he make, what the price is. I can guess what the V is, right? So that is very, very simple. Okay, that's very simple. You can estimate this rather easily. So that's why there's a many way to say the same theory, but you can see empirically some are easier than other, right? If you try to make a model to estimate U, it's very difficult, right? But once we make some assumptions about U, and it can be translated to V, and these prices, we can. So that makes things easier, right? Because by estimating the V, we can back out the U. Okay. So what I said is like, suppose I have a more flexible utility form, say x1 raised to the power alpha, x2 raised to the power beta, say for example, right? And this function we have alpha and beta, and this V with alpha and beta as well, right? We want to estimate that part, right? Estimating this will be very difficult because you need to observe what their utility and how much they consume, then you can estimate this alpha and beta. But rather, if you look at alpha and beta here, right? And you can then by tracing this, okay, then you can do much easier, much more flexible form because P and Y can be observed. Okay, but anyway, now before the break, we talk about what kind of restriction we can put on V, right? Because of we don't want to go with the U, we go to V, and what kind of restriction? Because this restriction will become your hypothesis because you do regression, right? Then you need to know, once you run it, you don't want to do hypothesis testing. You want to see whether a parameter makes sense or your assumption makes sense, right? The first two are trivial, right? The more money you have, you are always happier. The first one. The second one will be also trivial. The things are getting more expensive, you are not so happy. Okay. And the third one is also nothing surprising, is everything, the money and the income scale up, doesn't change your payoff. Okay. I guess the last one is the most interesting thing is if you're able to estimate V, which comes from our model, okay, then the partial derivative with respect to P and the ratio product with Y give you the demand function. Why is it important? Because we can observe X, right? And these two have parameter of alpha and beta, if you remember the assumption there, right? So by equating this, we can do the estimation, right? Without actually looking at the utility. Let me repeat what I'm saying, okay? We make some assumption on the V, right? And with some parameter there, right? And this end up with some parameter there with P and Y, right? Because V is a function of P and Y, right? And we can observe P and Y, we can observe this, so then we can back out those alpha without measuring utility. So that's the idea. Okay, I hope this is clear. Okay. I'm not going to the proof because I don't think you care. So that is the right identity. That's why it's important, because that is the way how you try to back out the equations. Okay. So I guess I should have a break, but do note that how to properly estimate this demand function remains a frontier topic in economics. So if you look at recent papers, top 5, always every other year you have 1 or 2 papers telling you that how to better estimate demand function, how to better estimate this utility, direct utility. Even you make a small progress, already get you away everything in the top publication, because it's amazingly hard to estimate those. Of course, for your research, you only need to look at the frontier, right? But if you want the methodology changes, for this, it'll be very tough. But these are the still active research, because we really want to estimate this, right? Because at the end, right? When estimate how people behave, right? By looking at this, if you know how to estimate this parameter thing, then we're happy, right? Because that can tell us a lot of stuff, right? And that's also a million question in Amazon, Taobao, Tmall, those marketplaces. They do this every day, okay? Change the price a little bit here and there to look at utility, right? Okay. So let's have a break of 15 minutes. And in the meantime, as I said, we should have a form. Tell me how well you're doing. I'm too fast, I'm too slow. But the absorb period is not over. So that means that I'm still doing an anonymous survey. But after the absorb period is over, I will do a name the surface as a way to take the attendance. Okay, so you can just tell me any question you want me to go over in more detail. Okay, I'm a little bit slow in the first 2 classes because not many of you were taken or still remember intermediate micro, so I just go slower. But after that, I think the technique, we do differentiation all the time, so I'm going faster, especially for the second class. I'll be going faster. But we are sure to finish chapter 1, so don't worry. So that's a break. Let's resume at 10:40 or 15 minutes break. Feel free to walk out a little bit, because all sitting there make your tummy big. Blood circulation and some issues. So just walk around, talk to your friend, or if you don't feel very happy, walk around. Then you get out of the room, and you got a corner. Hi. So very good. At least 7 of you are filling. But after actual period, like next week, we will be compulsory asking you to fill in as a way to check the attendance. So I guess let's show the result. First is sometimes in the proof, but understand the insight. Yeah, that is the different part because it's an insight that matter, right? But the math also a bit bigger. So I send a proof, but it's a market insight, that property that matter. Of course, you have to understand the math first, right? And then you can try to see how you can use it. And quite honestly, you need to take some time to work out of it to goes on. And there are too many formulas. I guess if you look at any textbook, actually, we are made it already extract the minimum of it. Okay, but as I said, you don't need to. You can forget about the thing in the gray. Okay, the only thing I need you to look at is the in the slides would be the green thing, right? Or the blue is the main definition. The green are the results, and the red one are the examples. Okay, so that is what I expect. The other gray one can be ignored. And at the picture level, I don't think I can't really go to every single thing because there are too many things to cover. Okay, so I try to give intuition, and that's the reason you need the homework. The homework asks you to rework all the math, recreate the mechanics there. It's very hard. I mean, if I go over every single pages in detail, then you will at least cost us say 2 semesters, 3 semesters to go over everything. I mean, since you're PhD, I mean, you should try to help yourselves. But of course, that's why we need tutorial. And usually I would be around to answer questions, right? So, but for sure, when I first study, I don't fully understand, okay? I mean, at least for advanced micro, I at least learned 3 or 4 times. When I was a master student, I learned it once, right? When I got a PhD, I learned it twice. And at least for not 1 year, 2 year. I have 4 courses of my advanced micro, because in the US they would have first year you have 2 year, two semester micro, and second year you have specialized micro. Then you take another. So I have 4 micro, and of course when I do research and also I teach and I do a lot of micro, and I can say I don't understand everything. Even for myself, I taught the class. So it's not possible to understand everything, but the important is take the skills that you from this class to build a model. That's the main point. So I'll talk about the project. Someone asked me during the elevator, but I will talk about that. We have some assumption whether you know the intermediate micro, but I try to be slow because already slow. Some of people already said I'm too slow, but I try to be slower. That's why I review. I spent first hour to review what we done last one, right? But as I said, you don't really worry about the proof, but rather give you the idea what's behind, because I understand some of the emotion, but okay, if that's the case, I will try to slow down it further, but that's okay. I mean, slow down a little bit of keep this pace, but that is what have to be. Okay, so just to remind you, today is not Monday, so in case either you are not aware or you just fill up the first answer. Yeah, so everyone is awake? Yep, that's right. The speed is okay, but as you said, some people said it's not following easily. That's good. So that being said, I mean, I would say this class is not super easy because we have many things to fill in, right? Because you learn the consumer, producer, equilibrium, and then you learn game theory. So we try to cram everything in single semester. That has to be something you can't understand everything, right? I think the same for regression. I think you run the regression. I don't think everyone will understand all the mechanics, right? All the asymptotic, I don't think you get it. But you still use it anyway, right? You still run the regression. So same for same for theory. I don't think you have to understand every single theorem, every single property there. You may understand some of them, that's okay. When you need them, you just get it back, right? So don't worry about it. When you do research, you are not alone, right? You have your advisor, your co-author. You understand what the part you understand, your co-author, your boss understand, then the paper still works. So no one understands everything. So don't try to, it's not like the undergrad master, you understand everything. It happened, you don't understand everything. Okay. So it's okay. So you have to deal with the problem. But anyway, some of you asked me during the elevator, what's the project? I just upload that. That's why 1 minute late from the class, but in the break. So I just uploaded in the Blackboard. So what's the project there? The project actually is the way you apply what you learned from this class, in fact, right? Because it's a model-related project, means that you have to do something with the model. And this is what the class tells you, I guess, cover also almost every aspect you may see in the model in your research as well. So there are 5 ways to complete your assignment. So either you write a complete paper, you can write a complete theory paper, that's fine. Some people do it. I'll show you some example there. Or you can write a proposal, okay? And you can write not a paper, but you say, I want to do this. What will be my model? What will be my prediction? And that's okay. You don't have to do the complete paper. As long as you describe what you're doing, what you expect to get, I think it's fine. And you can also, if you don't have confidence to writing a model, you can even do simpler. You can look at what are the theory paper there, summarize what they are, point out what they haven't done, and what you might be doing. That's also fine. Okay. Or even simpler, you can pick up a recent papers in the top business journal or the journal in your domain, and you figure out that, okay, there may be something can be done in extension, that something is lacking, you want to change it. What you can do it, or you can describe it, that should be fine. Okay. Or you can pick up an empirical paper, okay, and they have no model there, okay. You can write toy model. You can modify the toy model in the literature. That's also okay. So I guess it's not something too demanding, but it should be doable. Okay. And in the past, all the students have no complaint on this one, at least as far as I'm concerned, but shouldn't be an issue there. Right. The worst case is you do literature review, right? Just pick up some paper there, they do some theory, then that's also okay. So shouldn't be something that super difficult to do. Okay, and then the submission deadline in the last day of the semester, 1% of the grade. Okay. And I will expect you are writing 10 to 20 pages, double-sized written report. Okay, and the paper should have your name, title, how you typeset that thing as a very minor. And here, I'll tell you how you start. You can follow asking yourself some questions. And once you answer them, you would know how to do it. Okay. I'm not going to go to this in detail. Rather, I want to draw your attention to some example that people submitted last year to tell you that this is possible to do it. I'm not showing every single paper there, but rather I just want to show you some of the paper. So this is the work actually done by my student. She wrote a review on some theory paper, and actually she developed this paper in the second half of semester, means early this year. So she wrote this last year, and then this year she finished this paper, and then actually she presented in some international conference there. So you can extend this paper, and then you just write this paper is how to rank scholar and how to rank journals, and then he summarized the literature and then something to be done. So this is the her work. So basically just telling bunch of math and bunch of things have been done. So we just review and some thing that can be done there. So just point out what can be done. So it's not something require you a lot of work. But I hope this project can be helpful for your own research, or at least for your own interest as minimum. So you can see people can take the paper, actually make it to the real part of the dissertation. Okay? And this is the economics problem. And since we have 5 students from accounting, probably I should mention about accounting paper, right? So there's a paper about demand, supply, and auditing. So it's something very economics, right? And what these students do, right? If you can look at that at home, but it's going to tell you that, okay, there's some utility function which actually we cover today, right? We cover utility of the entrepreneur, okay? And look at the demand supply. The entrepreneur want to hire auditor and decide many things, and then there's type 1 error, type 2 error, liability and regulation, and then discuss how thing changes and do a contracting model, and that there's a something that in the literature have been done well, and there's some missing that he discussed how things should be there. Okay, so that is, and when there's ESG, then how we change the audit market and so on and so forth. Okay, and there's another paper talking about I think it's a real estate student talking about hotel policy. I don't know, it's marketing hotel policy, some behavioral pricing, and the students looking at there's some behavioral pricing in the literature, and the cancellation policies because he or she want to combine the two things, and then he consider a model to build up how to understand the behavioral pricing and cancellation policy, and there's a hotel problem there, and there's a fill some gaps there, so you can see not something you need to write down the full model, at least to point out what can be done. I think it's also good pieces. And maybe I put a finance paper there because I guess that would be. So this is a paper that recently people work about on sustainable enterprising ESG problem. So basically just review what have been done, okay? And just review to look at it and critical review, I think it's fine, right? So it's not creating anything new, right? You can see, so there's a paper here, and then there's a standard excess return, but there's a element there, which is going to be the ESG thing. Okay, this is a different from standard asset pricing model, and there's a bunch of math, and then comment on what have been done, and then there's a he implies some modeling there, and he derives something that is already in the literature. So there's nothing, it's not original in this section. Then, but he starts to comment on what had been done, and have some idea how to change it. And there's a we will not set how the factor is going to changes, and there's some modeling there, and then he just try to discuss on those. So I guess that's pretty much of that, right? Because I'm not asking you to do a lot, right? Double-sided 10 to 20 pages. Shouldn't be spending a lot of time on that. Okay, maybe you spend seriously spending 1 or 2 weeks, then you're done. Okay, because we don't have real assignment for this class, right? So this is basically the only assignment and the exam, right? So shouldn't be this class is not very demanding. The reason is we want to give you more time to study lecture slides, because that would be the thing. Okay, I think we are in the slides. I think we are very concise already. It's a minimum you can do in theory. So I try to slow down, not to rush, but at least I will finish all this today. Okay, I can try to slow down a little bit, but so this is the problem. If you let me draw a picture, it'll be easy to understand. Okay, maybe that's a whiteboard. Okay, that's good. So if you look at the thing we study, if this is good one and good two, there's two good world, right? The consumer would actually face this downward sloping budget set, right? The budget line. This would be y over p1, right? And this is y over p2, right? So this is the constraint he face. And how can we choose the best bundle here, right? If you recall the method we do is in the undergrad, in the intermediate classes, you keep drawing in difference curve, right? So you keep drawing different curves here, keep drawing there, keep drawing a lot of difference curves, right? And remember our consumer preference is monotonic, so which means that the northwest direction is always best, right? So what is the optimal there? And we learned optimal is the slope of this is tangent to the indifference curve, right? Because Wawa's law actually tells us it must be on this line, right? The problem is which point of the line. And then we tell you that it's optimal must be the case that when you try to draw that guy, it must be indifferent, right? It's a tangent there, right? Because tangent there means that at that point, you don't want to change, right? So you can see the idea here is we fix this budget line and moving the indifference curve, try to look at which one highest, right? Because highest must be the one that almost tangent, right? So if you learn linear programming, this maximization problem is actually, you can reverse it, framing about minimization problem. So here is, I fix the line, I find the best curve. But you can reverse it. I I fix a curve, I move the line. What do I mean by that? It will be like the following. It will be, I still have this line, right, this graph, okay? All I do is I fix a particular indifference curve, okay? I want to find the least expensive bundle to satisfy this, to achieve this utility. So this, from maximization point of view, the minimization, I find the least expensive bundle to achieve my utility, okay? That means that I would try to draw different budget line in parallel, right? Because you change the slope the same, but only the y changes up and down, right? So you just basically keep drawing this parallel line until, sorry, not very parallel, but forgive me if I are using a mouse, okay? So this is the solution. So this is what we call the expenditure minimization problem, okay? I think if you learn intermediate micro, you learn it. If you learn principle in economics, you don't learn it, but that appear in the intermediate micro. I mean, of course, many of you haven't took it, so that's maybe a little bit challenging for you, but this is what in linear programming called duality. So you maximize something will be same as some minimization problem there. And you often, in theory, you often see that happening. So if you don't know duality, doesn't matter. I don't know that before I go to grad school anyway. So there's something there, you know it, that's it. Don't worry about that. But the good thing is these two are closely related. Okay? And there's something you can borrow from here. Sometimes it's very difficult to solve. This is much easier to solve. And sometimes this is easier to do empirics. So that's why people solve in this. So basically just like, in other words, on a problem, you solve the other one is easier, then you go to the easier one. So there's nothing very special, but it's a math technique, but also makes sense in our cases. I want to do that. What is the cheapest way to do it? Okay. And here, the other way is I want to make myself as happy as possible. Okay. Under how much I have, right? So this is the same thing. This UMP, this is EMP. Okay. So I hope this is clear what we are doing. So the problem is when you just flip around it, you're minimizing how much you spend, right? Because that means that you are looking at the parallel line there, such that your utility achieves certain level there, okay? At least a level given. So this U bar is same as Y, it's part of the model. So the minimization problem to solve it, you have to give me prices and utility level. In the utility maximization, you give the prices and income. Okay. Of course, something you will complain is, how can I know this number? Okay, that's another issue, but it's just a construct. Okay, it's just a construct. So we never know this guy, but anyway, just say something you want to achieve. It's a construct. So let's see some implication for this is if the price are positive, your preference monotone. Price positive means that everything is you need to pay. Preference monotone means remember more the better, right? And the first is the constraint must be binding. Why important? First is this must be binding, must be equal sign. The reason is if this is not equal sign, then you can reduce something there to make this less expensive. So optimal, this must be binding. So that is the proof I written down in the black one. But as I said, no one care about the proof anyway, but just write down there. If you just want to check about that, okay? But there's not something there. But why is it important to make equal sign? Because make equal sign, in math, this is a constrained optimization problem with equality constraint that you can solve by Lagrangian. If this is not the case, you have to use advanced technique called conductor condition. That would be way much more difficult to solve, right? So that's why it's way much easier. Okay. Now, probably not surprised to you, which you have seen already, the optimal condition is the same, right? But actually, it's not surprising because if you remember the whiteboard, the best case should be parallel, right? Imagine this is the curve. You move up and down, you must hit his bottom, right? I don't know how to call that, but imagine his bottom is here, right? Just hit there, right? Just keep moving until you stop, right? Because you go further up, it's more expensive. So you want to the lower one, right? Because if you, this is the budget line, right? It's all parallel line there, right? The higher the thing is not so good. So you want to find the minimum of the line such that you still achieve the green thing there, right? Right? Because we told you monotone, so it must be on the green line, but it's which one? Then it must be this guy, right? You can keep going up. Okay. So, okay. Of course, we still consume convexity. Remember, we have convexity, monotonicity, okay? It's still there, okay? And continuity. So still we have to assume this three condition for this to hold, okay? Of course, it has to be differentiable as well, but that is something implicit there. But okay. Again, you can, while you get it, you just send a Lagrangian. I'm not going to solve it out because you will be working on an example, right? So let me jump to here. You can actually solve this model in this way, and then you figure out what is the function there. And once you solve this problem, okay, you get how much you consume, okay? And this function, depending on prices and utility level, is called Hicksian demand, okay? The thing we learned in the maximized utility is called Marshallian demand, okay? This is called Hicksian demand, okay? Of course, this thing is hypothetical because you can't really say this guy, okay? But Hicksian demand do have some nice property. We'll talk about that, but and also there's some nice thing there. Okay. So as we talk, this when you solve this problem, you fix this guy, you move around the indifference curve. Sorry, you move on the budget line. This point is called the Hicksian demand, we just said, right? Hicksian, or sometimes the book called compensated demand. Okay, the Marshallian with ordinary demand function, but there are many names. I'm sorry about that, but there are too many people give same name for the different name for the same thing. So I have to tell you what that. And when you have compensated demand, you have a C there. Okay. And there are many property there. The first one, probably trivial, is if the price are double, your demand is the same. Why? Because the price ratio has no changes. You still consume what you want because you have infinite money anyway now. You have no constraint. You have to, what you do is to figure out what is the consumption to make you the same happiness, so then achieve happiness U bar. So it is not, you don't worry about money, right? So that's why you consume the same bundle as before, right? Everything become 10 times more expensive, you still do the same, right? You're not to achieve that utility level. So that is the first thing. The second thing is possibly very nice, what we want to have is the demand, right, is always non-increasing in prices. So this is the way thing that economists try to look at for many years, right? Because I want to, the price is getting more expensive, I should consume less, right? It may not happen in Marshallian demand, but it always happens in Hicksian demand. So that is a little bit here because later you will see because of there's no income effect in this model. Your income is always get compensated. You just consume. So later we'll see why the difference between these two, because there's an income effect and substitution effect. In here, in the Hessian demand, only substitution effect there. There's no income effect. We'll talk about the Sluggy equation very soon, but here's the reason why when you, in the Hessian world, this is down sloping demand, always down sloping, okay? There's no way you can do, no way you can give and good, okay? And this is here, and there's a the same idea, but not gross complement, but net, because the income effect is gone. We'll talk about income effect very soon, but that is the definition there, okay? As I said, some of you mentioned there are many terminology, but they're just definition. So I don't think I need to explain with just the name, okay? If I go through every definition, that is very boring because nothing to say. Just, okay, this is net substitute, then come out. There's nothing to prove here. So that's why sometimes I just skip a little bit faster. Okay. And here comes our last function, right? Because at the end of day today, we learn four functions from this chapter. First is the Maxwellian demand in direct relative function. And we just learned the Hessian demand. The very last one is called the exponential function, okay? Which is saying that you give the price, you give me this, how much I spend, right? So basically just asking us, what does that mean? It means the following. Just let me show you again this diagram. When you're here, right, this is y over p1, right? Exponential function is asking where this guy is, right? Because this how much you spend, right? And similarly, in fact, in directive function is telling us what is the utility function here, right? So asking where this guy is, right? Give me p and y, where in the indifference curves we are, okay? So this is the graphical meaning of this. So basically, just like I solve the problem, we have the Hessian demand, right? I have demand for each good. Amount the price, right, is actually the how much I would spend. Okay. Okay, so that is the idea there. So I think it's explained here, right? So as you see here, right? So this is the exponential over the price. Oh. Now there's some property here. The most important, of course, is the last one because it has empirical content. But at least I want to go over one by one. I think the first one is very simple, as we've seen. If every price is double, your expenditure is double. Why? Because your demand remains unchanged. That's Hessian demand is homogeneous at degree 0, right? You don't change your demand when the prices changes. So that means that your expenditure will just double because you keep consuming the same thing. So double the price, don't change your consumption pattern. That means that the cost of it is double, right? The second one is price goes up, expenditure goes up. Okay, that is also trivial. Okay, something is not so trivial is why this concave impact price. Okay, which means that if you have two prices, you consider the combination. Okay, and the combination of the expenditure is less than this one. Okay, that requires some proof. It's very interesting proof, but I'm not going to talk about that. You can check the slides there, but probably you may ask why I do that because it's a concave, then you can derive some nice property there. The concave, you can have empirical content. But the most important part is this surface llama. If I have utility fund expression, I define the price, I get the Hessian demand. Okay, so that is has some empirical content there, because as long as I can estimate that, I have some way to tell me how consumer consume. I look at the price changes, I can figure out the demand. Or the other way around, if I have this one, I can back out this equation, estimate those, right? Because I can observe this after price. I can go back and estimate this expenditure function, right? Because expenditure I can observe. Price I can observe. Consumption also I can observe, right? So there's some way you can do things, okay? This is a proof, okay? So you should be able to do this type of problem, okay? You solve the equilibrium and figure out this expenditure function. So as I said, don't worry. Assignment 1 will make you work out all the example again, okay? And then you know how to do it. And as unfortunately, PhD level class has to be like this, okay? Has to be rushed through, because if I go through every single pages, we can't go anywhere. Because you look at the textbook at MWG, it's like 1,000 pages. So if I go through, I can't really go through every single thing, right? So, but do note that because of the time, so we only cover a very small part of MWG, maybe less than 100 pages throughout our course. But so I guess the most important part is how these things are related, okay? And why this is important, because actually would tell us very often in empirics or in discussion, we also mention income effect and substantive effect, what they are, okay? And this comes from this equation, okay? Because why we need to solve two different methods and come with different result, and then what does it gain from us? Because it tells us a lot of stuff. And is this because of the income effect, substantive effect, and tell us how to decompose it, the changes, the compressed statics into different aspect, right? Different dimension. Because as I told you, for solving a model, solving equilibrium later in game theory is not very fun. The most fun part is coming from when you change the model, you see how the equilibrium changes, then you can have empirical content, right? Because you learn these days when you run regression, right? And you base on some probability changes, right? Diff and diff or regression discontinuity, right? That's based on some probability changes. You can do it, right? Same as the theory, right? By itself is not meaningful enough. And the most common thing in this demand system is the price changes, right? So the substitution, this lucky decomposition is about the price changes. So now let's dive in. So because the UMP and EMP are the same thing, so that means that if you write this Hicksian demand, we're same as the Maxwellian demand, but the income replaced by the expenditure function. Okay, this is a statement. I don't prove it. It requires one-page proof in this. Okay, but I think it's very intuitive. And the other way around is you have a compensated demand, but the utility replaced by the indirect function. They're the same as the Maxwellian demand. Okay, of course, this is a technical thing, only because we need to derive the following result. Okay, you can take it as granted. If you want to check the proof in the book, 1 page or 2 pages of proof, because it's too mathematical for us to handle it. But this duality, I think, is very simple, right? I think you can see maximize, minimize will be the same thing. Okay. So here is the following. The most important thing is here. So I changed my price of good I. How we change the demand for good I. So this is the Maxwellian changes. Okay. This is something you observe in the real world. Remember, something observe in the real world because you change the price, right? We keep your income there. Okay, change the price. Change the price of good I. How it affect this customer's consumers' demand. Turn out, if you will prove it in the next slide, I think, can be decomposed in 2 parts. Okay, the first part is the Hicksian demand. Okay, and later we'll mention this is indeed the substitution effect, which is always negative. So price goes up. For one good, I should demand the good less, because other good, because monotone, right? It's more expensive. I should able to spend less on that one, spend the other more, because this become more expensive at optimal, right? Because at optimal, this is more expensive. But in the original, your MRS should be same as price ratio, right? Now your price goes up, right? Then you should spend your money elsewhere, right? Because originally there's some optimal trade-off, right? Now you increase the price. So that's substitution effect. But this is not the end of story. There's one thing that here. It's called the income effect. Okay? And the income effect is what? If you learn intermediate micro, what it said is the following. So if you maybe draw a graph, it's better. Yeah, this way, right? So the substitution effect, so this is the price here. You change the price, this is the final outcome. Okay? The Hessian is keeping the utility the same. So you just basically looking at which point under the new price ratio where you are. And this is the Hessian effect. As you can see, you are sliding on the same indifference curve. So that's why this is always positive. Because price reduced is always positive. And you come from here to here, it's called the income effect. And this can be positive or negative, depends on how the shape you are. It can be here, so it can be negative, depending on the shape. So this is here in this example, but it can be here, so it can go negative. Okay? So the substitution is pure negative. And it can be moderated by the income effect or reduced by income effect. And remember what the income effect is. If the good is normal good, then this negative. If this inferior good, in this case, it's inferior. So the income, you have more money, then you spend more. Sorry, this is not, sorry, that's normal good, right? You have more money, you spend more, right? If inferior good, then go backward. So depend on the good is normal good or inferior good. Okay? So that means that if you try to then, and also income effect can be very big. Okay? So so it depends on how you want to expect what with the demand function the slope looks like, right? Will be dependent on two parts. First is suppose I reduce the price of one good. Okay? You want to ask, okay, how it change the demand? So you have to decompose it into two elements. First is how this good trade off the other good, right? You ask, is there any something similar to this good? Okay? If there's not a lot, then substitution effect will be very small. If there's a lot, then this will be very big. First thing. The second part, look at income effect, right? And suppose the price goes down, right? What means that is you have more money to spend, right? Because even the guy who keep his current bundle, he will have extra money to spend on the same good or other good, right? Suppose McDonald's reduce the price or canteen reduce the price. Then you save some money. You can spend on the good, same good, or spend other, right? So then it depends on it's normal good or inferior good. If normal good, you spend more on those, inferior reduce, okay? So decompose in two parts. So this decomposition is very useful. I mean, not just for this example, because you always, when you talk about price changes, always income and substitution effect, right? But it's good example to demonstrate when you do computer statistics, it's good to decompose it in several parts. And when you talk about in empirics, there's many things you can say because you can tell the story by decomposing in multiple parts. It's very often you will see that as well. And very often, actually, in an empirical question, you ask also same, right? You ask what is, you look at the empirical question, you check, okay, the first regression tell this changes, right? But how so, right? What is the intermediate variable, the mediator variable there to lead to these changes, right? So this is the idea, right? This is actually holding you to the same, what you will get, right? And this is allow the income change back, you allow this changes, right? You keep change things one by one, right? It's like regression, right? You holding you hit the same, this is the effect, right? And then you allow this to change again, right? So that's how you do the thing. And then a lot of time when you write the theory model, when you write a toy model, try to see if a very complex equation, you are able to try to decompose it in multiple parts. That is very useful by construction. But let me go to the math, because I think this is most important, because that is something you don't learn, usually don't learn in the intermediate micro. In the micro, this is the end of story, usually, right? This is a graph you learn in the intermediate micro. There's nothing new from the micro. But why is this, right? The proof is like this. It's actually one line of proof, okay? Just one line. Maybe two lines, but you can say just one line, okay? Remember, this is the equation that's given, by the common set demand, right? By replacing this by exponential function. Because this must hold because of duality, okay? Now, you partial differentiate P. So left-hand side is nothing, but just same thing. But the right-hand side is a little bit difficult because yes, P, right? So when you learn calculus, it tells you that you take the first argument, which is here. But the second argument, you chain rule. You differentiate this with respect to the E and E with respect to P, right? And that's it, almost here. You just put this guy on the left-hand side, almost here, right? But yeah, right? Just put this to the left-hand side. This here, this to the left-hand side, this guy. And of course, one more line. Because of surface llama, change in E and this is C. So let's replace that guy by this guy. Okay. And here a little bit, one more is at the optimal, this Hessian demand is same as the Marcellus demand holding relative constant. So everything gives you the Schluck's equation. Okay, that is that's behind the graph, right? Total changes. It changes along the way if you keep it the same. And this is the income effect. Okay. Let me show you again the equation why this fit. Okay, this is change in P, how X changes. And this is change in the demand function, keeping utility the same. That's the function there. And what's left here will be the income effect, right? And as we show you that already, this equation, this is always negative, right? And this depends on whether you're normal good or inferior good, okay? And also depend on how much you are consuming on it, right? If initially your consumption is very low, the income effect is very small. So that is very important observation there, right? Because we not just decompose in two parts and tell you what the income effect determine. If your current consumption is very low, the income effect is very small, right? As well. So that is a lot of content here, right? Although there's something looks very trivial or very simple, right? If you understand what's going on in the graphically, but it tells you that the income effect depends on how much current consumption you have, right? If you have a lot of consumption here and it's a normal good, then things can change very different. Okay. So I hope that now it's more clear what's going on. Is there any question? I'm sure that is not something easy to digest, but if you haven't learned anything intermediate micro, I'm sure that is very difficult. But you learn it, it becomes trivial. So I find it hard to find a balance, because if you know it, then it's nothing new because I just do everything in math. But if you haven't heard about that, then everything is new, then it's very difficult. But just like you just asking, I have to tell you how to do intermediate micro in one class, which you should learn intermediate micro, you will learn one semester, half a semester, right? If you go to the econ department, you learn for undergraduate class, intermediate micro, up to here, without all the calculus, will be you spend half semester on that. So I can't really, go too slow I'm sorry about that, but don't worry. I mean, in terms of math, it's very simple. All right, but I hope you get the intuition. Okay. With that being said, let's have a break of 15 minutes. Let's resume at 11:45. At this time, I'll stay around to answer any question you may have. Okay. Or you have any question, just feel free to ask me. Again, let me open to you reply. Although I see you're not too interested in writing, but I just still doing it in case you want to keep going on, ask me question over there. Okay, let's have a break, and I will see you in 15 minutes time. If you have any question, please feel free to write down there. I'll try to answer them.我也不知道我那叫多快多慢。就杨一天天跟我说，开慢点，再快一点。所以我第一节课教快一点，虽然发现不能快一点，我已经要快一点，太快点不行了。有啊，就是那时候辛苦。但其实不一定不然对。知道达成你的目的是一件可消遣一下，更办不够。对，就也不喜欢对啊，对，但是这个但是我那个投资，我大概肯定包我一点，但是这个有我也包。哎，这个东方这个关系就是也东西的就是reference 啊 reference 它的好像可以都有像reference 就把这个3块。或者是其实就是大，那当然也可以设置 search model 或者 search， 基本上其实它的前6块人，对，也甚至找3块的3块不到，打不到就没有。哦，search model search model， 3别找个一个块人不要，其实你找到一半就找那个奥秘方式来用，对。对，你 search 两侧都不在在。寻找一个答案，寻找一个答案。这样子historical if the full 这个答案 all believe。快就是，当然你可以认。OK， 就这样的就可以说吗？你可以在那边这边，如果但是你不要可以对对对，这是一个很大的，当然这比说，
你看这个正好也经常忽然讲，哎，这个说什么都可以改，是在6岁来变得到概念这样子是的，但是我还有一种思维，那一考都大概是，对，因为考虑说我就单考一学，对，但你要很努力在做学，但是虽然我的那种都对我的感觉是一种，虽然它不好摸的。但是会特别稍微有刺激。我打很多人就是这个前面拍一些，哦，这样就这个或者哎，你可以咱俩在一起，我给他也挺不错，这个案子也很不平衡。所以对讲 process 研究上，很好的，这比较就很好的，还有点就是什么课展上面，也是什么 policy， anchor in the back as a search event。原来是 story， 哎，对这个东西的，这三个医学的故事是一个现场那个where my sign， 我的手里前面是他这个我给他一 base estimate， 好，不是那个好问题，那种啥，这个。SEP 法，对，有点是其实我还没通过的。
对，还没有。因为我们做 research 也是做 game theory 相关的这个。
我们的下半节就会讲这个 M.Phil， 就是 exam open book 是然后project science， assignment 就做6分。
这就刚刚上讲那个就是 project。
assignment 是做6分，就是
都做6分，
都做6分，就是不管对错。
没有 attendance。
没有。
我其实在预测那个之前上场面试，所以内容都是。
attendance 不是没有分，但是有些是小于20的话，我要报告给上面听。我不 care。
我的 attendance 是要通过
对，
所以我要填
那个对，这家还没有他们。这个是如果你连续的出席的话，我不会主动报告。如果有人问我有没有来的话，我就报告回来。但我 keep track， 我不会分享。如果你给了稍微麻烦了，就如果客人主动参加的话，我不会主动报告，我太消息了。然后没报，但是我不会主动说不出现，不做这个事。但是我不知道，一个其他客户出现，给老板其他人。我人家问我是，我得马上对我不会主动开始对我这样的话。也是没事的，反正我就可以，我刚刚应该有个超市，看你看到谁。最高了8分。首先，我们应该谈 anxious，一直播我。 所有这本书籍还是高级知识啊，所以它有然后它的没有数字，我哋就看出那么这个是哪里？也都是数字的。对，可以的。我们基本上也就可以。正常的 pricing 去做。You understand what normal is? Normal is. 因为 normal 就是现在所有的怎么可能？就我这条修嘛，它变错了，为什么？也有跟但是另外一个，这个东西加一个也是什么complicated？你要学这个还是有没有办法？就是可以有的话，一个今天的时间安排都是今天上午。首先，把这个赶紧出来，而且理财都往那里跑，首先。你在就是说就是比如说，也发生。对，但是这个都是我因为难得对迈入的地方，不能从人开始，不能从闷的人那种开始不着手的啊。有一点呢，但是因为是我以前上的这些东西在做事情嘛，就是刚刚都是给你 idea， 我会在看都是这样，就是这样的背景环境。就是在看的大概是对，跟他在说，到上有时候也这个讲的多，讲的但你有没有可以这样说？完全有奖励对别人。example 就是它6次。上一个 example 一样。差不多。 Even utility devices. Fund. I want to find how much energy严格来说，我们算是没有超过你别差很多的，靠这个时候靠2025，其他的地方应该还是因为我们都没有搞这个是 XMA 没有，就不知道，考那个没办法，因为讲太。So if you have a question, fill it in, then so far there's no one fill in, so that's okay. No one fill in, then we can quickly resume. So I know that many of you haven't learned anything about intermediate macro, but some people even haven't learned economics. So, but I assure you that you will find this class will be very useful when you read papers, because I mean, all the paper now we have some modeling part you have to work in, and this is very standard thing. So demand, supply, consumer, game theory. So what we learn in this class must appear one way or other in your graduate study. So that's why this class is required for all B school student, PhD student. Okay. So just want to say, I mean, my class is not PhD level, to be honest, because I just pitch in the level like master level. Actually, I would say my math requirement is less than in the econ department intermediate micro, because we don't cover a lot of technical details, just there. And we have some game theory. So basically say undergraduate level, I would say, but we pitch, I mean, for some intuition, we pitch a higher level, but for the math requirement, actually, we are not very deep. But the skills we use will be useful for your research, okay? But we skip all the math. So that's why not super complicated. But that being said, I guess it's always difficult for the B school student for these classes, always, because when I was in US and then I'm from econ department, I see people from the B school, then they always struggle because they haven't learned before, because we are econ, then undergrad or master we have econ, so we know what's going on, and they suffer a lot. They spend a lot of time asking us questions, but it's always like this. But I guess it's now these days, if you have a question, just ask AI what exactly it is, right? Then you should know, because we don't cover a lot of material. Okay. So I hope that's okay. I just only keep the main result. If you go to real PhD classes, they will just basically result the result. They do the proof and proof and proof and proof. Okay. I already excuse you from that. Okay. Just keep the very main thing there. So I think this is absolute minimum for you to be used for this class to be useful for the rest of your studies in B school. So I guess this is already the absolute minimum. You can't reduce
too much. So, or last year, actually, this is not black. I now make it black, so I just already kill a lot of stuff already. So I don't think you can kill more. And some of you ask me how I make the assignment. Assignment just say they tell you, see, just I'll give you this, you reproduce the rest. Okay. So, and I already told you how to do it. It's very mechanics. You just copy what I do. Okay. You follow the calculus and do the same thing. So you will see, don't worry. I think the TA will post it very soon and you have some idea what's going on. Or maybe, okay, anyway, to ease your concern, I show you what is in the last year assignment. This year's assignment will be very similar, but with some changes, of course. So will be something like this. So this is example I give last year. I've copied this function. I want you to calculate the MRS and how MRS changes with x1, x2. Write down the UMP, derive the Marshallian demand, and calculate the indirect utility function. Write down the EMP, find the Hessian demand, find the exponent function. So you will see something like this in your assignment as a part 1. So this is something you should know how to do it. I expect you how to do it. And as I said, this is intermediate micro. If you ask anyone from the econ department undergrad, they would know it because intermediate micro is the required class. So everyone in the undergrad, they know how to do it. So as I said, so I'm not asking a lot, okay? So although you may complain I do a lot of things, but this is only undergraduate level, okay? If you don't have study, then of course it's a lot of things to absorb. But this is undergraduate level, okay? Just to make sure. And there will be another question 2, which tell you some proof, but you can try to attempt that. But you will see the assignment. I'll ask the TA to put it up. So welfare, I don't want to spend too much time because this is just telling you that why we care about the indirect utility function. I don't want to go to any details, but I just want to say 1 or 2 things because I cut all the thing out because I don't want to spend more time on that one. So I want to mention one thing is something like this graph. Okay. Do I have a good graph? Okay. Maybe I draw one. Just this is important because so usually we have this. Say if you learn in the principal class, good, and the price, and this demand curve, right? So the more expensive the good is, you demand less, right? This is a demand, this is a price, right? But you write in this way, it's called inverse demand curve, right? Because demand curve should be x on the y-axis, p on the x-axis. But if you reverse it, it's called inverse demand curve. Okay. And very often you learn in the principal class, you will say, suppose this is the market price. Okay. And they tell you undergrad, this is the consumer surplus. What consumer surplus is? How is measuring how people happy, right? The larger this part, the more happy they are. Okay. And there's no foundation for that. And they tell you in the undergrad or high school, you learn economics, they say, okay, why this is the consumer surplus? Because the demand curve is representing your willingness to pay, the height. So the difference is the height is you pay this is how much you want to pay. The difference is how happy you are, right? And you buy this unit and some of this happiness is how good you are, right? This is what you learn if you ever learned before, this is measuring how good you are. And there's no foundation, right? Because it's just demand curve. Why demand curve related utility, right? Should be utility based. right? So be preference, how happy you are, because utility will be how happy you are, right? There's no foundation for that. And I want to tell you that I'm not going to do any proof or math because I guess it's too complicated. And you should measure it based on utility. And I would tell you that there are two ways to measure this, and consumer surplus is in the middle. So there are two ways you call, I'm not going to do detail, but it's something called CV or EV. And the difference like this, but I don't want to go to this because it can be very confusing. So, but what I say is there are two ways to measure this, and it's measured based on expenditure, how much based on money terms. And what I want to say is consumer surplus is always in between these two different measures and depend on inferior or normal. So consumer surplus is, although they don't have foundation, but it is capturing something that we want to capture. Okay, but I don't want to go to detail because none of you is going to measure unless you do public policy, and that is something not needed. So that just let you know, if you want to do policy work, then it will be useful. But otherwise, consumer surplus is okay. And for those who understand the antitrust regulation is happening in the US or everywhere in the world, consumer surplus is where the government approve a merger. Suppose two firms merge, right? Then you increase market power of that guy. And but also if you two firms merge, there can be some efficiency gain because the firm became more productive or more efficient, right? So when would the government allow firm to merge or not? Look at consumer surplus change, okay? And why this is valid? Because it captures these two measures, which is something we care. And I don't want to go to detail on that because I don't think any one of you will use it anyway. So that's why I skip this part, but it's a huge part when you go to public economics or IO regulation. Look at merger, that would be something very important. But I would just skip that part because you will often see consumer surplus. That's why I want to mention it. Consumer surplus is it's nothing. It's not founded in theory, but it actually is an in-between measure of something is well-founded. Okay, that's what I want to mention. Okay. So just to recap what you want to learn in the topic 1. Just make sure that you are okay. Just make sure that you are fine. Is basically this learning objective, right? So you know how preference go to utility. Okay, we start from the very beginning. See, so that's what the Elon Musk said, right? Start everything from first principle. So that's what we do. We start from preference. And some of you ask how our class is going to apply in your work if interested in behavioral thing, in marketing, or you want to know how price work in information or other thing. Always start with the preference. Okay. In our model, our preference is very standard. In your application, can be adjust accordingly. Okay. And you're still assuming that guy is maximizing something, and that something can be very behavioral, can be very crazy. But the technique of maximizing something is something you use. And maybe in your model, there are more constrained, more complicated framework, but the same thing. You just maximize something subject to something. And that's it. The same technique, always use it. And that's the maximization problem, right? And then the other way one is minimization problem. You also do the same, right? Although things are very complicated, they may be using the different utility function. You may have more constraint due to your framework. The same thing happen. Okay, And why I want to mention consumer surplus, okay? One thing is some of you, when you try to do a shortcut in your modeling, you see some, especially in B School Journal, they would just say the firm is maximizing consumer surplus. Because actually they do. Okay, although it's not valid result, but not valid in terms of not very well founded. But some people actually say, okay, in business model, they just say, okay, let the firm, when they do optimization, because they don't want to model this crazy thing, they make some assumption on the surplus and just assume the firm are maximizing surplus. Okay, ignore all this part. They go to the very end. Okay, that's okay. I mean, it's some shortcut because firm actually should maximize profit, right? But why he maximize surplus? He say in the long run, when you maximize surplus, and people will come in and buy your product. Okay, so that's a shortcut. But of course, if your model is very complex, that's okay. But if the model is not so complicated, that's a why don't you go from the very beginning, right? But it's okay. I mean, that's why I'm also consumer surplus, because it's measuring how the preference of the people. And at least if you really want to maximize consumer surplus, in your model, you understand this is actually coming with preference as well. Okay, so that's why I put consumer surplus there. But I don't have time to talk about those because of the time constraint. Okay. Is there any question? I know it's a rush for some of you, or maybe even many of you, but we can't really stop there because of not everyone use this, right? And because when we talk about firm, almost the same thing will happen. So don't worry, when we talk about firm, we will do the same again. So very soon we'll see when we do the firm, we'll do maximization problem and minimization problem again. I'm sorry, but we are doing the same thing again and again. Sorry, at least at a second time. So look at producer, because we are B school, right? Basically, we're working for firm anyway. So we'll try to draw similarity here. We will just apply what we learned in the first topic again, okay? And actually firm is easier. In person, you maximize utility. What's that? Right? But remember, utility is just your preference, right? You choose the best thing. But for firm, it's very obvious. You are maximizing profit as a manager, right? And maximizing profit. And what I'm doing is you're looking at what you can produce, right? It's a technology production function. And what the cost is, right? Look at input and output, right? Because you have to sell the output, you pay the input, right? The difference is the profit. And you try to make sure that you organize your input and sell the output, right? Such that you maximize the difference, right? And this is a maximization problem. But you also have a minimization problem is you forget about the production. You just talk about how to organize your input. Forget about selling the good. How about if I want to produce this much of good, how can I minimize my cost, right? So that's a two problem, right? Cost minimization and also maximize your revenue. So naturally, you have two different problems there, minimization and maximization. Okay. Do you know that in our model, we just do a very simple model. So the firm is very small. That means that the firm is price-taking firm. So he would take the product he can sell, the price he can sell, sorry, the price he can sell is given by the market. So imagine you're growing a banana. The price of banana cannot be decided by you, decided by the market. Or Coca-Cola. The price of Coca-Cola is determined by the market. You're not changing, no matter how many goods you're selling. And also he's a price taker in the labor market or capital market. How was the interest rate from the bank? He can't change it. It depends on the market already. Take it as given. Or how much he have to pay to hire a worker is also given. Okay, you may ask, okay, no way. I mean, we talk about big business. What can we do? That will be talk about game theory. Because if you change the market, you interrupt the market, then you require more tools. So what we're doing in the first two topics is we take the market as given. We just talk about internal, how you given the environment, you face it, you try to do things. So this is very general, right? Because you have environment, interact the environment, how to do the best thing. So it applies to every single context when you do modeling. Nothing but optimization, right? Because we have to optimize. Well, unless you say that guy is very stupid, he always does stupid thing, right? You don't want to assume that in business, at least, right? So that is something we fit our model. Sorry. So we will have two things: cost minimization, I mentioned already, and profit maximization. Okay, and as you can see, the cost minimization doesn't care about how you sell the good. So this is not the dual problem of the profit maximization, right? Because cost minimization is just very simple, just operation management, right? You how to combine your inputs to produce output. And they don't talk about it given the output target, right? You're doing that, okay? And the problem maximization is you have to design jointly how you produce and how much you produce at the same time. Okay? Because the profit maximization will have the concern of how many units you're producing. Okay? And the cost minimization is saying that I want to produce this much, how I organize my input, how many workers I need, how many capital I want, okay? So on and so forth. Yes, your question? Yes. So the problem maximization problem include cost minimization and how you produce. Yes.
So if like the deal problem.
Oh yeah, if you do this, but the cost minimization usually what we mean is we don't care about how to sell the good. Just say I want to produce 10 cars, say suppose Elon Musk, and how I put the human, how I put the material, how I use which technology I'm using. So that is the cost minimization problem. But problem maximization is just asking, okay, I'm facing the whole problem. I need to minimize my cost. I want to choose my revenue because of given technology. Okay. And we have product surplus, which turned out to be, not surprisingly, something very simple, just profit. For a firm, product surplus is just profit. Okay? So there's nothing controversial about that. So one thing you have to remind you that one thing I missed is the firm here is a black box. There's no manager, right? If you tell MBA student, they will disagree, right? Because that's the value they are, right? They organize the thing, they tell you how to do things, right? There's some of you go to industry, that's why we make money, right? We tell them how to consult them, how to organize their stuff, right? And there's no optimization within the firm. The firm just a black box, take input and spew out output, okay? It's a machine there. But you know from organizational economics, from manager, if you're the manager, Ph.D., then you know you would have to the internal structure in the firm will be very important, right? So if you have time, then game theory, we talk about contract theory, we talk about mechanism design problem, we talk about how things being organized, right? Whether you have a hierarchy of firms, and whether within the big firm, right, people are doing politics, right? And these things can be modeled in game theory as well. But we just forget about it, right? The firm is something there's no human, right? So those people who do audit or accounting, they will hate it because the entrepreneur is absent from this thing, okay? So there's no manager ownership problem. If you do finance, corporate finance, people would be hating it as well because we just skip all those things, okay? So let's get started. The problem. The first thing is, you may disagree or not, but this is what we start. We assume firms are profit maximizer, to maximize profit, and that's it. Okay? Some people would argue, wait a minute. In China, we don't maximize profit. We maximize market share, right? We burn all the money and kick other people out, and then once I've done, I become monopoly, I increase price. But remember what you said at the end, you increase price at the end, right? That's the ultimate goal. right? You're not doing a charity, know the price, and fight, then all die, and then you win, right? No, you have to wait the end, you earn profit. So it's here, right? Although in the short run, you want to maximize market share, but at the end of the day, you want to maximize profit anyway, right? No one is doing charity at the end, right? But of course, you may ask, in the short run, they also want to maximize market share, okay? But in that case, we will leave it for the game theory. Game theory, you can do it, no problem. So our model is very simple. It's a long-run idea, right? At the end, maximize profit. So that's what we have. As I said, you can open the black box of the firm. There will be a lot of stuff there. But just assume a firm is a small one, okay? It's very simple. Now, I try to now draw the parallel between consumer and the firm because I said there's no difference between firm and consumer because they're also maximizing under a given situation, it's interactive environment. Okay, so you think in this way, so everything we learn is very simple, right? Because it's maximizing under the environmental constraint. Okay, so no matter what you do in your modeling, it's always like this. I hope that makes sense. And consumer, what we have said is he is a transforming goods into utility number, right? More high the number, the happy, they consume the thing. Same here. For the firm, it's transforming input to output. Okay? And in the consumer is the utility function or underlying the preference, right? Preference can be the function. And here is the production technology. Okay? Is the technology tells us how we can transfer input to output. And to illustrate this, in math here will be the following. Now we are also in the m-dimensional number. And now we relax the idea that we are now negative. Okay? And negative is very simple. Negative means this is your input. Okay? Positive means output. So if we write this, y negative 1, 2 means that we use 1 unit of 1 to produce 2 units of 2. If we have this, means that I spend 1 unit of 1, 2 unit of 2 to produce 3 units of 3. So this is very generic, right? And this plan tells us what is feasible in technology, right? You can imagine maybe in this case, this iPhone, maybe this is 1 labor. You need 1 labor to produce 2 iPhone, right? And in this case, maybe 3 is 2 iPhone, right? Maybe you need 1 machine, 2 labor to produce 3 iPhone, something like that. Okay? So very generic. So that means that I can describe things in this way, very convenient. Well, why we want to have this kind of crazy thing? Because you can imagine in the world, right? One firm's output can be used for the other firm input, right? So by doing this way, then it's very generic. So economists spend a lot of time to figure out this is the right framework to do the right thing. Okay? But of course, our life is precious, so we don't want to deal with so complicated world. But first is like what the feasible thing, okay, is the y. Okay. So let me draw a graph before we end the section. I don't want to continue because it is. This is good number 1, this is good number 2. Okay. What technology tells us is the following. First, I will tell you one thing is this part is not feasible. Why? If this is feasible, then we are rich forever because we create nothing from nothing, right? So that cannot be this thing. you must be consuming, you must do something, right? So the only feasible part will be something like this. This is feasible, okay? And of course, this is stupid, right? Because you just burn things out. But doable, but you don't do it, right? So typically what you will see the production feasible plan with something like this. So this is something doable along this, right? Here simply means that you use good 2 to produce good 1, right? Any point there, right? You consume 2 to produce 1. And here is you consume 1 to produce 2. Okay? Is that clear? And of course, very often only one of them is feasible, right? Because say suppose 1 is labor, 2 is iPhone, right? Labor can produce iPhone, right? iPhone cannot produce labor unless the iPhone become a machine that can have a baby, but otherwise, right? Machine cannot produce labor. At least produce human, right? But maybe machine can produce labor, but that is plenty. But don't worry, we will not use this complicated framework. We will later you will see we will go back to the undergraduate idea. We only have single output and many inputs. So it's an intermediate micro idea. But of course, you can see the framework is very flexible. I can have multiple input, multiple output, but we will only focus on single product firm. We will not talk about multiple product firm. Yes. Oh, you can be something like this as well. Can be not be this, can be something typical. Can be something like this, right? You need certain kind of labor to produce iPhone, right? Because maybe 1 person cannot produce iPhone. You need 10% to a factory. You can be like this. Yeah, just constraint. This is what is feasible, right? Because just like the consumption, right? How much you can have is restricted by that. But the consumption is usually don't have much constraint. You can buy as much as you want. But the firm, what you can produce is technology. And we are economists. We are not engineer. So this constraint is given by engineer. Engineer tell us this much of input can produce this much of output. And this engineer constraint, you can say. Okay? So I'll see you next week. The assignment will be given you too soon. And then I think the tutorial will be conducted at the end of next class. So next class at the end of next class, the TA will come and talk about the assignment. Okay? I think they should give you 1 week to do it. So just submit it. No matter you submit, you get a grade. So just don't forget to submit it. Just do it. It's okay not knowing. You say I don't know. I think it's okay. Just don't leave it blank. Okay.